All right, test for a function graph. And in brackets, I have the vertical line test. Now, to be a function, every vertical line that can be drawn through the graph of the function must cut the graph only once. To be a function, every vertical line that can be drawn through the graph of the function must cut the graph only once. If it cuts the graph more than once, the graph is not the graph of a function. So if a vertical line can be drawn that can cut the graph more than once, the relation is not a function. All right, we're going to have a look at example 4. And then I'm going to ask you to look at examples 5 and 6. All right, I'm just copying example 4 so I can always see it. So example 4, I'm going up to the top. Now, example 4 says, if it is given that f of x is equal to x squared, where x is any real number, we're asked to show that f of x is a function. We're to determine the codomain of f of x, and we're to find the range of f of x. All right, so here's how I would go about doing that. I would go about answering this question by first drawing a sketch of the graph. Now, a sketch of the graph of f of x is equal to x squared would look something like this. So I draw my vertical axis, the y-axis. All right, let me just, the graph of y is equal to x squared is a parabola that cuts the y-axis at the origin. So the graph of y of f of x is equal to x squared would look something like this. Now, you must have an appreciation of what this graph will look like. Well, in order for you to answer the question, now we're asked to show that the graph is a function. And remember, what I said to you earlier is that in order for you to show that the graph is a function, you need to do a vertical line test. All right, so I can draw a vertical line through the graph. You'll see that the vertical line that I just draw cuts the graph only what? Once. You can also imagine that every vertical line that can be drawn will cut the graph only what? Once. So is this a function? I would say yes. F of x is equal to x squared is a function. And if you want to give an explanation, you could say every vertical line So I'm putting that in bracket. Every vertical line that can be drawn through f of x is equal to x squared, that can be drawn through the graph of f of x is equal to x squared, will cut the graph only once. Therefore, f of x is equal to x squared is a function. B, determine the codomain. Now, you could consider the codomain to be the values of x which are used to determine the codomain, or the domain is already given. The domain is given here. We're told that the domain where x is every element, or x is an element of the set of real numbers. So the domain is the set of what? Real numbers. Now, let me give you a minute to think about it. What is the codomain of f of x? And C, what is the range of f of x? You can type your answer in the chat. All right, so B, determine the codomain. All right. So B, the codomain is y is an element. Y is an element of the set of what? Real numbers. Your codomain elements are all possible values of y. But the range elements, these are values of y that have a corresponding x value, would be the range is y is greater than or equal to 0, or you could say y is an element of the set of what? Positive real numbers. Y is an element of the set of positive real numbers. All right, example 5 asks us to identify the domain and range of y is equal to 4x minus 3. Now, what I would start out by doing is to draw a sketch of y is equal to 4x minus 3. It's not a graph, it's a sketch. And this is using my knowledge of coordinate geometry. First of all, y is equal to 4x minus 5 is a linear graph. And it's a linear relationship. And the graph of a linear function is a straight line. So that's 1. The gradient is positive 4. Therefore, from left to right, the graph is going to slope up. The graph cuts the y-axis at minus 5. Minus 5 is the y-intercept. So if I did a sketch of this graph, it could possibly look something like this. So it's just a rough sketch. This is x. Right here would be minus 5. This is the origin. And this is y is equal to 4x minus 5. All right. Now for this question, we're asked to identify the domain and the range. Now, first of all, a line goes on forever in both directions. A line goes on forever in both directions. That's the first thing. All right, so I was saying that a line goes on forever in both directions. Now, when you think about your domain and your domain element and your range elements, you're thinking about what are the values of x and y which are used to draw this graph. Now imagine this line going on forever in both directions. It means therefore that to draw this graph, you would need every value of what? X. Now, since it's going on forever, up and down, to the left and to the right, it means therefore that you're also going to need every value of what? Y to draw this graph as well. So that said, it means therefore that the domain is X, which is an element of the set of real numbers. Everywhere, for every value of X, this graph exists. So the domain is X is an element of the set of what? Real numbers. The range is Y is an element of the set of real numbers. For every value of Y, this graph exists. For every value of X, there is a corresponding value of Y. And for every value of Y, there's a corresponding value of X. This graph exists for every value of X and every value of Y. Therefore, the domain is the set of real numbers, and the range is also the set of real numbers. Example 6. Now, example 6 is asking us to find the range, the domain and the range for Y is equal to, that says X cubed, but it should be X squared. So let me tidy up that quickly. This should be X squared. All right, so the approach is going to be similar. I'm going to start by drawing a sketch of this graph. Now, the most important thing I need in order to draw this sketch, I need the turning point. Now, for a positive X squared graph, there is a minimum turning point. Now, so what I need to do is I need to determine the turning point. One way to do that is to complete the square. And completing the square means to arrange a function of this form, ax squared plus bx plus c, into the form a into x plus h squared plus k. Now, we can do this using a formula approach, in which case h would be equal to b over 2a, and k, I think, would be equal to 4ac. I think it's minus b squared over 4a. So we could do it using a formula approach. The simplest approach, though, is to first find a. So for the relation y is equal to x squared minus 3x plus 2, a is 1, b is minus 3, and c is 2. So h would be equal to b, which is minus 3, over 2 times a, which is 1. H is minus 3 over 2. That's h. All right. Now, I can find k using this formula. So I could say that k is equal to 4 times a, which is 1, times c, which is 2, minus b squared, which is minus 3 squared, all over 4 times a, which is 4 times 1. So this is 8 minus 9 over 4. K would be equal to minus a quarter. So h is minus 3 over 2, and k is minus a quarter. Now, what is the significance of h and k? The turning point is minus hk. That's the turning point. In this case, the minimum turning point. So h is minus 3 over 2. Therefore, minus h is minus 3 over 2, which essentially is what? Positive 3 over 2. So therefore, minus h, which is what? 3 over 2, k, which is minus a quarter, is the minimum turning point. It's a positive x squared graph, therefore it will have a minimum turning point. Now I can now make my sketch of the graph. I have my y-axis. I have the x-axis. All right, let us say that this is 1 and that this is 2. That down here, this is minus 1. All right, 1, 2. So my turning point is 3 over 2. 3 over 2 is 1.5. So it's 3 over 2 a quarter minus a quarter. This is y is equal to minus a quarter. This is x is equal to 3 over 2. So my turning point is here. I didn't bother to find the intercepts because in terms of, for what I need to do, I don't need the intercepts. I don't need the x-intercepts. All right. I'm just doing my sketch. So my graph would pass, look at something like this. All right. So let's do that again. I think the graph would pass in something like this. Just trying to sketch. We could try and pretty it up, but it's a parabola that looks something like this. All right. Now, from this, we're to determine the range and the we should determine the range and the domain. We're to determine the domain and the range. Now, earlier I said that this graph is going to go on forever to the left, and it's going to go on forever to the right. So I could basically say that this graph exists for every value of x. Because this graph goes on forever to the left, and it goes on forever to the right. Whenever we draw a graph, we only draw a part of the graph. We draw a graph for a limited part of the domain. But if we imagine this graph going on forever, unending, never stopping, it goes on forever to the left, and it goes on forever to the right. Therefore, the domain of So this is A of f of x is equal to x squared minus 3x plus 2. The domain is x is an element of the set of what? Real numbers. Now, they didn't ask us for it, but the codomain would also be the set of what? Real numbers. Now, this graph, however, does not exist for value. It does not exist below the line y is equal to minus a quarter. So for x is equal to minus 1, this graph does not exist. The graph does not go below x, y is equal to minus a quarter. So therefore, it means that the range are the values of y where this graph exists would be the range of f of x is y is greater than or equal to minus a quarter.